Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 792, the number of matching subsequence. Given a string S and an array of strings words, return the number of words I that is subsequence of S. We need to understand what is the subsequence. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining orders, which means the string is a subsequence of itself. So for example, ACE is a subsequence of A, B, C, D, E. So you will notice here, by deleting character B and character D, we form the subsequence ACE. So subsequence is different than the consecutive subsequence. So that's kind of like two of the, I would say, sometimes people confuse between the two concepts. So in this case, it does not have to be consecutive. So A and C, they are not adjacent to each other in the original sequence. So by taking out B and D, we got the subsequence ACE. So please note that A, B, C, D, E is also a subsequence of A, B, C, D, E, so itself, because it indicates that the deletion can be none. So let's take a look at the example. In example 1, the string is A, B, C, D, E. The words are A, B, B, A, C, D, A, C, E. There are three strings in the words that are subsequence of S. So A, C, D, A, C, D by deleting B and E. A, C, E by deleting B and D. B, B is not subsequence because there was only one B in the original string. In the example 2, so you can check this example as well. It has two sub sequence. So one we can easily tell is, okay, so this one we can easily tell AHJPJAU. So you can find right in the middle. JA, you can find it as well. AHB is not, because let's say this B does not match any character in the original string S. Similar with this TN, the words start with TN. So this TN does not, the TN didn't occur in the original string. So how to solve this one? Okay, we can try the most brutal force way. So basically, take each words from the words. Let's say take A, and then start from the beginning of the string S and try to do a matching. Let's say if we can find a match for A, if we find, okay, so this A is the subsequence. Let's move on to the next BB. In this case, by loop, okay, we point our initial position B, and then we, for the string, we start as our initial position. So at the beginning of the string, A, so A does not match B, so move this one to the next position, B, B match the B. Okay, so in that case, we move to the next position of the string, and then here we move to the next position of the word. So it's the second B. And then as you are moving here, so you cannot find another B until you reach the end of this string. So there's still one B hanging here in the original word BB, so we cannot find a match. So in this case, this is not a subsequence. So we can do this brutal force way for all the words, for all the elements in the words list. So in that case, what is the time complexity? So remember, for each of the words, you loop through the string, and then for the worst case scenario, you have to reach until the end of the string in order to determine, okay, whether or not that word is a subsequent of S. For example, in the case when we check if BB is a subsequence of S, we need to reach until the end of S in order to determine, hey, if we can find the second B or not. So in that case, the time complexity would just be O, the length of S times the length of words. So the length of S could be really big, so 5 times 10 to the power of 4, and the word length could be 5,000. So if they are both at their upper boundary, upper end, so the overall time complexity, when we multiply those two lengths together, the worst case scenario the worst case scenario, it could be 2.5 times 10 to the power of 8. So it can be quite large, and then it will likely result in the time exceed the time limit. So can we do better? So I think during any interview, coding interview, it's always helpful to first describe the brute force solution quickly, and then try to improve after that. So on top of that, so that will shows that okay, you first have at least have a very basic idea for solving this. It may not be optimal, but at least you know how to solve it. And then after that, we can start brainstorming and thinking about if there is any better way or a more optimized way. So here, so what we can do here is actually one of the idea is to create a dictionary. So this dictionary indicates the words in the all the words in the words list. So basically, we use as the key. Key is the first character A. Let's say in this case A, and then the strings in words. All the word, for example, words I with starting with the character A are A itself, ACD, ACE. So it covers three of the elements in the words. And then the remaining one, BB, that starts with B. So we can initially create a dictionary like this. And then basically, what we are doing here right now is, let's say we just loop through this as, in this solution, we are trying to loop through this as only once. So not for each words. So previously in the brute force way, we loop through this as once for every element in this words list. But right now, what we are trying to do by creating this dictionary is we are trying to loop this as exactly once for all the words in this list. So how it works, let's say starting from the beginning of S, we encounter an A. Okay, so we know A. And then we look for this A in the dictionary we just created. So we look for this A in the dictionary we just created. And then we find out, okay, we have an element A, ACD, and ACE. So in that case, so A itself is a standalone element. So here we just cross out this A. We already find one. We increase the counter by one. And then what's left here? So let's say we already encountered A. So in that case, we only need to track, okay, the part after the character A. So that's CD and CE. That's why we create a new key value pair. So the key is, okay, the new start of the new starting character, that which is C. So C correspond to CD and CE. And then this A, all the elements has been removed from this A. Why? Because we already processed all the words start with the A. So in that case, we find one subsequence for A itself. That's why we cross it out after increase the counter. And then we take the starting character A from the two words ACD and ACE because we already encountered A. So in that case, we put the remaining part into the new under the new key. So they happen to have the same key C because CD and CE they all start from the character C. So in that case, we form a new key and key value pair. In that case, we loop through the S, check the next character, that is B. So in that case, we check the dictionary for key B, and in this case, B corresponds to the word BB. So in that case, after this update, so after processing B, so our new dictionary looks like this. So we cross this letter B out because we have already encountered that. And then what's the remaining part? It's still B, and then it starts with B. And then we move to the next character C in the S as we continue looping through all the characters in S. So for this C, we check for the keys. So in this case, after process C, what we get? So we get something called D, and then we got a new key called E. We still have that C, so let's say we still have the C, but it's just like empty since we have processed everything in C. And then we moved on. So the next character in string S is D. So that's D. So in that case, we are trying to look for the D. So okay, cool. So here, for the key value D, the corresponding value, let's say we only have one D left, and then that's the length of it is 1. So in that case, we finish processing this one. We can increase our counter by 1 as well. So in that case, we update it, and then remember, we increase the count by 1. Here, after processing A, we have the count plus 1 as well. So now we have already successfully processed the ACD. And then here we continue loop through the S. So we move to the next position, E. So, and we are looking for the key E here. So basically similar to how we find the ACD. So after processing E, in this case we find it, and then the length of that is 1. So we just update it. So in that case, we finish processing all the characters in the original string S, and then we find all the matching subsequence, and then we just return a count. So you can see how this algorithm works. So in this case, the complexity will just be the length of S, because we loop through the string S once. So initially, we create a dictionary, basically by looping through the words to create this dictionary. But this is outside the loop for the to iterate through the string S. So they are kind of execute one after another. So that's why it's not nested loop. So in that case, the time complexity for constructing this dictionary is the length of words. So in the worst case scenario. So in that case, comparing the length of words with the length of S, so basically the time complexity for the entire algorithm is the O n, and then n is the maximum value of the S dot length or words dot length. So whichever is bigger. And then what is the space complexity? We create an additional dictionary to keep track of that. So that would be the O, the length of the words. Cool, let's start coding. So basically for word in words, we are trying to create this mapping dictionary, default dictionary list. So still utilize from collections, import default dictionary, and we are trying to initialize. And then for word in words, so mapping word 0 dot append word. So that's kind of how we create this dictionary. And then after that, let's try to loop through the string S for I in range length S. And then trying to check if the mapping is I which means, let's say, it's not empty. So for example, for this key value, we have a key A, but the value is an empty list. So we don't want to process that. So because it's already, everything has already been processed inside that. So that's why we utilize if mapping SI to check that. And then for the subword in mapping SI, basically remember, let's say we find A and then we just loop through everything inside basically every word with the starting character A. So that's kind of how we do this loop. And then if the length of subwords equals 1, we need to increase our counter by 1. So we need to initialize a count variable to keep track of the number of subsequence. So count. Else, if the length of the subword is greater than 1, so in that case, mapping subword 1 equals dot append subword. So basically what this does, basically this is corresponding to how we convert from here to here. We take out the first character A, since A has already been processed, and then we just created a new corresponding key value pair based on the part left after taking out A. So this is what this part does. And then after that, let's say, okay, we just return count. So let's run the code. I made a typo. Okay, I got an incorrect answer. So, okay, where did I do wrong? So mapping subword dot append subword starting from the position 1. Okay, so let me see, where did I do wrong? For word in words, so mapping word 0 dot append word, that's kind of how I created the initial dictionary. And then count equals 0. For I in the range of length string, I just loop through that. If my SI exists, basically for that corresponding key, it's not an empty list. So I just loop through everything inside that list. If the length of subword equals 1, then I increase my count plus 1. I increase my count by 1. Else, I just create a new key value pair. So basically mapping subword 1. Basically I take out the first character. I already processed that. And then I append other characters following that. So it's 1, starting from the index 1 to the end. Okay, so in this case, why I mistakenly count the word BB as a subsequence here? Okay, if my mapping SI. Oh, I think I forgot one thing. So I need to update and remove the already processed word from it. So here, I already finished processing it. So okay, so in that case, I need to do the updates. So I think I find where I made the mistakes. So I need to update it here from the original ones. So that's where it got messed up because of the B and B. I see. So in that case, my mapping. Okay, let me see. What if my subword length is not 1? And then my so if my subword 1 equals DSI. Okay, in this case, I create something called dot subword. If my subword 1 equals to the start of the string, equals to the SI, yeah, basically for this edge scenario. Okay, what we need to do is basically at the very beginning, we utilize a list equals mapping SI. And then for the subword in the list, and then after doing that, my mapping SI assigned to the empty list, and then I loop through. If subword else, I just append the subword 1. That's kind of how I do the update. So let me run the code again. Okay, so I corrected the error I made previously. So what did I do previously? Previously, I just checked by extracting the value from mapping SI directly. So now I create a temporary list and then assign the mapping value, mapping SI to that. So basically, if we look at this example, I create a variable called ls, and then I assign this one to the ls. And then I just check every subword in the ls. And then if the length of subword is 1, I find one subsequence. I increase the counter. Else, I just create a new key value pair by taking out the starting character, the SI, from the subword. So in this case, I avoid the mistake I made previously. Let's say, what if the SI equals to the subword position, the character as subword word position 1. So let me try to submit that. Okay, it's accepted. I think I want to go back to this problem and discuss the time complexity. I think I made a mistake previously. So for the word in words, mapping dot append. So create this dictionary. So the time complexity is O. Let's say length of words. And then by looping through this length, the string s, so the time complexity is O length of s. And then within each of the mapping, I do another loop. I check for subword. So in the worst case scenario, let's say in the worst case scenario, all the characters in the words are the same. Basically, we have the words of the same. Let's say they all have the same initial character. So let's say A and then A itself, or maybe ABB and ACD, ACE. So in that case, the worst case that this one has the length of words in the worst case. And then for the inner and outer loop, so the worst case scenario, the time complexity is still this times this. So that's the end of video. If you like my video, please don't forget to subscribe to my YouTube channel. That would help a lot. Thank you.